Hi from the Desk of Lay Data.
Hello everybody, it's me, and I've got a cat with me, and that's how you know it's time to do some engineering. When MOSFET appears, it's time to pull out some CAD. We are still doing our 10 series of Pi Zero videos for the Hackaday contest. We'll be doing our last one tomorrow. So get your Pi Zero ideas warmed up, enter them into that contest, and we'll talk about that, of course, tomorrow and wrap up our video series. You still have a couple weeks to enter that contest. However, tonight, I thought I would take a little bit of a break from Pi hacking. I love hacking pies, but maybe time to do something a little bit different. And I wanted to work on an CAD object for the SAM R21 G18, which is a chip that's very much like the SAM D21 G18 that I've been working with. It's in the Feather M0. It's a Cortex M0 Plus processor that's the same as the chip in the Arduino Zero, so it has core Arduino support. What's really neat about the SAM R is the R stands for radio. It has an AT89RF233 also in the chip as a system and package. So it's got two dies and they're wired together. So it's kind of neat. You basically get a Cortex M0 processor and 2.4 gigahertz radio that can do 802.15.4 or Zigbee. It's not going to be able to do like Wi-Fi or Bluetooth. I mean, I guess technically you could maybe write a core for it, but basically it's meant for like lightweight 2.4 gigahertz radio transmissions and receiving. And I think there's a couple of wireless protocol stacks that are ported to the AT89RF233. So we'll check that out when we get to it, but for now we have nothing. We don't even have an CAD object. So I thought let's look through the data sheet and maybe also look through the eval board and get something put together. Sort of just get a circuit board, a prototype made. This is the beginning of a new project. So let's go to computer cam. No problem. All right. Meanwhile, oh, and then I'm sending out the boards for Circuit Playground. So if you've been watching before and you've been like, hey, like you were working on Circuit Playground, what happened to that? It's still going to be coming out. I'll show it off real fast because I did generate Gerbers and send them off today. So I'll just show that off real fast because it's kind of cool. But this is the final design and a rendering. Phil B did a really lovely silk screen. Kind of cut the top off of this circle so that the USB port overhangs just a teeny bit. That's all good. Just got everything labeled very nicely. The reason we took a 2-week break is we wanted to get FCC and C certification completed, which we did. It all passed. We have certificates for that. Also ICES, although we don't label it. So we wanted to be able to put the marks on. So I didn't want to send off PCBs until I got those FCC and C certifications done. This is going to be the developer edition, and that just means it may change in the future, but this is kind of like our first version that we're going to be releasing to the wild. So I'll be ordering those PCBs. Well, it's Friday, so probably Monday is when they're going to actually be formally ordered. Get the PCBs in 2 weeks, and then we'll go through the process of designing a tester and all of that good stuff. So that's going to be very exciting. Okay, so let's close this up. And so what we were going to do today is I'm going to spend just a couple minutes and design a CAD object for this, the SAM R21. Comes in two types, S21E and 21G. We'll be using the 21G, but basically this has in-system flash. It, I guess optionally also has serial flash, 12-channel DMA, event system, has the 2.4 gigahertz ISM band transceiver, data rate of 250 kilobytes per second, real-time clock, timers, counters, eyes towards C. It has built-in USB host and device. That's kind of nice because you can program it over a bootloader. I actually don't know if this kind of radio, I don't know that much about radios. I don't know if, like, you know, the fact that it's an ISM band radio, does that mean it can't do, in theory, Wi-Fi or Bluetooth? I don't know if there's a certain kind of radio that you have to be to do that. I just don't know that I know that there is no existing code core for that. So let's skip ahead. Can read this summary, but we want to go to let's see. Okay, so we're going to be doing these at SAM R, so it's RF21, and it's going to be a 48 pin. And then 18, oh, I see, you can get the 19, and that has extra half a megabyte of flash. That's kind of cool. I wonder what that's all about. Comes in MU or MUT, so that's QFN, and that's what I'm going to be going for. Let's see if we can get to the pinout. Come on, here we go. Okay, so this is where the party starts. So this is going to be similar to the @SAMD. See if I can skip ahead to this one. The @SAMD has way more options. So this is the J. This is like BGA, and then this is the G. Okay, so this version, and then you've got this version, and they're going to be similar, but like flipping between the two. Okay, so it looks like at the top you got mostly the same, except reset is called reset N. That's pretty much the same thing. On the left-hand side, it looks like this has crystal 2 and 1, and this side has PA 2 and 3, so that's changed. Ground, VDD, looks like there's 2 more power pins. So this is not completely pin compatible. It's close, but it's not completely pin compatible. And then there's actually quite a few more VDD IO pins. There's VDD A and A. I think, that exists, but it doesn't have AVDD, ground, analog. VDD IO is down here, ground is here. Let's see. Just kind of flipping between the two to get a sense of what I'm up against here. Oh wow, this is a VDD IO pin. 17 is VDD on this one, and it's ground. So yeah, don't try to solder this in, your old short power to ground. And then here's the RFP and RFN, so that's your RF output. And then there's grounds surrounding it, so that's why they renamed these pins. And then on the right-hand side, there's also another power and ground pin. So basically, there's just more power and ground. It could be like, in the die, because it's 2 chunks of silicon. They actually have to have more bonding wires to get to them. I don't know. It's interesting. There's a significantly larger number of ground and power wires. Oh yeah, that's fine. But yeah, mostly what we really have to watch out for is this section, because that's the RF output. It's kind of nice though. I mean, like, it's all so integrated that you just have like RF out. Okay, so let's open up this, and then I'm going to actually make it into a feather, because that's kind of the easiest way for me to process this. Like, making an eval board for it, I might as well just basically make it 0, but I'm going to call this the 0 SAM R. Oh, and then I got a lot of versions. Let's rename Rev C to Rev A. And this will just give us, the structure, the power supply, the USB connections, all that good stuff. Okay, so this is the PCB that we'll be adapting. I don't know if we'll get to it today, but we'll start, and then I'm going to open up the library. So open up this library, and we already have the QFN object. Now, it's always wise to go to the end of the data sheet. Usually it's at the end. Maybe it's not. But sometimes you get the mechanical shape of the QFN. Ah, come on, where is it? I don't know if the index. I don't see it. Wow, there's a lot of errata. Let's see if it's at the beginning. QFN 48. It says QFN 48, but what size? I guess I'd say, look, I happen to know that they're the same mechanical sizes. I don't know why it's not labeled in here, but could be that they have a different data sheet that has the package reference where they show you the pinouts, but I happened to have compared the two sizes, so pretend that I didn't, and I spent more time researching it. Okay, so we will use the same QFN 48. Actually, let's find out what is the SAM D21. That's on D21J. Oh, this is actually misnamed. Hold on. Let me rename this. This should be G. Oops. Well, that's fine. So it's a this is a QFN 48.7 millimeter. So we're going to be using that same package size. So let's grab SAM D21. I'm just going to copy this and then modify it as necessary and make a new one called SAM R21G. Is it? I'll put 21. That's fine. Create a new symbol. Paste it in. And then we have to modify this to remove the pins that don't exist and do exist here. So we'll just go starting with pin 1, and we'll just make sure that they all exist and delete anything that shouldn't be there and add anything that is missing. Okay, so starting with pin 1, PA00, got that, PA01, and then PA02 and 03 actually don't exist here. So we'll get rid of these. Bye. And when we actually do the binding of the package to the layout is when we'll actually get to find if we made a mistake. We'll be like, hey, that pin's not supposed to be there. That pin's there. And then instead we're going to add two passives inputs called Crystal 2 and Crystal 1. Okay. So PA0, PA01, and then we have ground ANA, which we'll need to duplicate here. Actually, maybe it's ground. Sorry, ground A already does exist, but we need a second one. And then I can never remember, is it? I don't know if that's how you do it. I'll just call this 1 for now. Okay, because we have 2 of them. VDDA, got a VDDA, and we also have an AVDD. Hold on, let me compare this to. This has VDDA. It's actually have both. You know what? I'm actually going to change this to be more consistent. I'm going to rename these. So I'll rename this to analog, and then I'm going to make a second one. And there's also a VDDA. That way I won't get, because I'm not sure what the differences are between analog and A. One might be like RF power, and one is the actual analog core power. AVDD, ground 1, okay, so I got these 4. Ground ANA, VDD ANA, AVDD, and another ground ANA. Okay, and now back to pins. Pin A04, got it. Pin A05, fine. PA06, PA07, and then we skip to do VDDIO. Okay, got that. And then a plain ground pin, got that. And then back to PA08, PA09. And then we have another ground ANA. I have to remember, K-Town once showed me how you make these all. I think we just combine them later. So let me duplicate this one and this one, because we get 2 more of these. And we also have an output. I don't know where I'm going to put this. this down. Make a little room. Call this RFP. So if there's positive and negative, I guess there must be a valence required. We'll find out when we get to the eval section. Okay, and then we have another ground ANA, that's fine. PA, okay, so 10, looks like we have to get rid of these 4. So that would normally be, oh weird, they moved PA8 and PA9 down. Weird. Okay, so they got rid of 10, PA10, and PA11. So let's get rid of those. Later. PA10 and 11 are gone. We do have PA12, PA13. I'll move these up. Whoop. Actually, should I move them up? Nah. Never mind. Change my mind. Back to normal. We'll have the gaps. That's fine. That way, if I copy and paste this to another board, I can switch between the two. Okay, we've got PA12, PA13, PA14, PA15. Okay, that's fine. 16, 17, 18, 19. And then looks like PA20 and 21 get removed. Is that true? Yep, those were there. So delete them. Later. And then instead we have another ground and a DVDD. Very exciting. I'll maybe organize these later. I don't know, whatever. I mean, they're all going to get connected to 3.3 volts, so I'm not too concerned. Okay, PA 22, 23, 24, 25. Okay, and then we have a VDDIO, which we already do have. That's already there because it's the same, VDDIO and ground, so that doesn't have to be changed. And then PB22, yep, got that. PB23, got that. PA27, yep, got that. Reset, I got a reset here, that's fine. PA28, yep, that's there. And then, let me see, ground and VDD core are the same, VDD in is the same. The only thing is, this reset is reset N, and over here they actually put a bar over it, which is kind of the correct thing to do. So, nothing changes with these two, VDD in and VDD core, still there. And then PA30, got it, and 31, got it, and PB2 and PB3. So those are fine. And then, let me see, I think maybe, hold on, did I? PA0, PA1, PA2, PA3. Oh, you know what? I don't believe I deleted PB8. PB8 and
Here's
PB.
a question.
Oh,
Do
yeah.
you try to mimic the physical layout in the schematic?
I don't, because I want to group the pins by function, because if I was mimicking this physical layout, then I'd have like grounds and powers coming out in every direction. I don't want that. I'm going to connect these all to 3.3 volts, so I might as well just stick them all over here. You know what I mean? Like, all the grounds and powers should be together. Okay, hold on. PB8 and PB9 also get deleted. Beep. And then, oh, you know what? Maybe this was this a J? I think that these PB10. Oh no, it is there. PB10. Hold on. Oh, 1 second. I'll clean if there's extras or ones that I'm missing. I'll spot them when I do the pin assignment. That's when I do my cleanup. I think I mixed up PA10. Yeah, it's a PA10, PA11, PB10, PB11. Right, so I have to delete those two. Yeah, see, because they mix up the pins. It's like port A, and then, sorry, over here, you see port B is over here, and port A is over here, and then they have port A, and then they like stick port B, two of them in here again. Like, I don't know. I'm sure there's a good reason, but it's not linear, so I'm not going to be linear either. All right, I think that's it. So next step, we're going to make an object and combine the two. So it's going to be at SAM R21 G18. Make it, and then we will add the at SAM R21 object, and we will also add the TQ, not TBGA, I'm not doing BGAs, TQFN 48 7mm, and this is the MUR variant prefix IC, no value, connect. Okay, this is the party. So this is what you don't want to get wrong. You get this wrong, you're not going to have a good time. So go through it. I always hit this window. I kind of want to like...
Do you mind answering another question?
Sure, yeah.
Well,
yeah.
this is related to the new product video.
Yeah, go for it.
So the Arduino 101, does it have Wi-Fi?
Yes, it does.
Doesn't seem to be mentioned anywhere, though.
Is that so? Okay, now I'm actually curious. I thought it did. I'll be honest, I have not actually turned it on. I have one, but I have not. I've been doing other things. I could have sworn it had Bluetooth and Wi-Fi, but I might be completely mistaken. Okay, so it definitely has Bluetooth. I think it only has Bluetooth. Yeah, I'm sorry. It has 2.4 gigahertz, but it has Bluetooth, not Wi-Fi. Forget what I said about Wi-Fi. I was thinking of the Maker 1000, which is a different product.
There you go.
Sorry. That's why. Yeah, it does have radio, but it has a 2.4 gigahertz radio, but it is Bluetooth only because it's a low power radio. The Edison, however, I think the Edison has Wi-Fi. Now I just want to make sure I have the right thing. I believe, yeah. The Edison has Bluetooth and Wi-Fi. The 101 is also an Intel board, but only has Bluetooth. Okay, knowing is half the battle. Okay, back to the party.
What's the other half of the battle?
Getting the right pin orientation. Okay, so first off, make sure it's not bottom view, as we've learned. Like I know Atmel doesn't do that, so that's a good thing. And also, you can look at the order of the pins, which is another hint, by the way. It should go in a counterclockwise direction, starting at the top left. If it's not, it's probably bottom view. Although, by the way, recently I had a data sheet that said bottom view, but it wasn't. It was top view. What? Yeah, it happens. So be paranoid about that. But triple check that you have the correct package, because it is rare, but there are some situations where the SOIC and DIP they look the same. It's two rows of pins. They have different pinouts. I've had it happen to me. It's also extremely rare for the QFP and the QFN to have different pinouts, but I have seen it. It does happen. So be very, very careful. I've seen much tragedy when an engineer will blindly say, "Oh, it's quad," and they follow the QFP, and then they don't realize that there's a slight pin difference between the QFP and the QFN. Nothing is knowing the dimensions of the QFN, but you can measure that with calipers. Make sure, because it's QFN 48. It's not like DIP, where it's like DIP is DIP. There's like 0.1 inch spacing between the two, or SOIC. It is very well defined. QFN, you can have 48 pin, 5x5, 6x6, 7x7, 8x8. You can have any size. I don't like that they don't say QFN 48-5x5. I think they should, but sometimes life gives you a data sheet, but the data sheet doesn't have the information the way you want it. That's how it is. That's fine. So let's do this thing. We're going to start pin 1, go around. So you just be super careful. Watch out for port A and port B because they look similar, but they're not. Connect PA0 to pin 1. Pin 2 is PA01. Then we'll go down to crystal 2. Crystal 1. And while you're doing this, once in a while, it's like kind of fun to just like click, 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 but also just align up, make sure you actually have the right pad. You know, you should sort by the pad, but it's always good just to, you know, triple check what you're doing. Okay, pin 5. It is ground and a first one, then AVDD, and then, sorry, see, I'm already making mistakes. It's VDD ANA. Analog, and then pin 7 is AVDD, then back to ground analog, then we can go back to ports, PA04, PA05, PA06, PA07, and then once you do a road, triple check, okay, I'm on pin 13, that's correct, VDDIO, because if you get this wrong, man, you are going to be so sad. Like if I've made a mistake once, I swapped 2 pins, I was like not paying attention, and it's like tracing it out and figuring it out. It's a real pain, but you don't notice by the time you got PCBs.
Quick question: are you gonna have an RGBW featherwing?
Probably not. Probably not, because I like the little mini ones, and they don't come in RGBW yet. But if they do, I'll have a party. Okay. PA08, PA09. Okay, pin 17 is. Hold on. Oh, come on. Scroll. Ground analog, another ground analog pin. Pin 18 is RF positive, then RF negative. Ground analog. PA12, PA13, PA14, PA15. Okay, check. Okay, right, we're on pin 25. Let's move this over. PA 16, 17, 18, 19, and then just a plain ground, DVDD, PA 22, okay, we're on 32, so PA 23, PA 24, PA 25, and then I have a ground. Oh, you know what, I'm missing a ground. Okay, I'm going to skip ahead. I'm going to skip 35, go to 36. VDDIO. Oh wait, is there 2 VDDIOs? How did I miss? Oh, there are. Uh-oh. So I have 2 pins that are missing. So this is where I'm like, oh, I'm gonna go back and I'll fix that. So let's go forward to 37, PB 22, PB 23, PA 27, pound reset, PA 28. And then I have a ground that I'm missing. I didn't make enough grounds. VDD core is pin 43. VDD in is 44. PA 30, PA 31, PB2, PB3. Okay, so I am missing 3 pins. Not a problem. 35, 36, and 42. All good. Go back to at SAM R21. And we're going to make, I'm pretty sure this I can do, is it at 1? And then I'll make another one. And then I need another VDDIO. And then I'm pretty sure it was, you do the at sign and that makes them appear. Is that right? It's been a long time. Actually, no, what I do, I remember what I'm going to do. I'm going to connect them instead. I'm going to do something else. I was complaining. Okay, hold on. Let's go VDIO, VDA analog, AVDD, VDDN, VDD core, DVDD. And then I'm actually going to do, I'm going to do the trick that I keep forgetting to. I'm going to delete this ground and then these analog grounds, save this, go back to the object, and then I'm going to merge these. You'll see what I do. Because there's only ground and there's only basic digital ground and analog ground. I don't see any other kind of grounds. Okay, put this here. Why is this floating? Okay. So I'll have to reconnect some of these pins. I'll be really careful. Okay, so pin 8 is ground ANA. So you do this, and then you click append. And now this has, whoa, it's weird. Oh, hold on. Oh man, come on. This connects to 2 pins, 5 and 8, which is correct. They're both ground ANA. I'm also going to append 17 and 20. Beep, beep. So now these all connect to 1 pin. It's a cleaner way of doing it. I didn't used to do this. I think they maybe added this capability later in Eagle because I learned on Eagle 3 or something. And so I just never did it. But then K-Town showed it to me and I was like, oh yeah, that's a good idea. 29 is plain ground. So I will append that here. I'll close this up. And then 35 is also ground. I'll append that. 36 is VDD. Why do they have? Oh, they have 2 VDDIOs because there's 2 chips. I'm sure that's why. Because I was like, why would you do that? There's 2 chips. I wish I could. I want to get an X-ray so I can show the inside of these chips because I think that'd be neat. All right, so I appended VDDIO. 42 is another ground. A lot of grounds. Got a lot of power, a lot of RF. And then thermal, I'm also going to append to ground. You probably don't have to connect thermal to ground, but you know what? It all makes routing so much easier, anyways. That I don't leave it as a separate pad. I just tie it to ground, and I'm done. Okay, so now that we're done, yay! We'll go to schematic, and I'm not gonna. Maybe I'll do more of this tomorrow, but I'll just put in the object. So use this object, and then I'm gonna implement it, and okay. So I'm gonna be kind of bad. I'm just gonna drop this in, and not all of the pins are the same, but I'll clean up the pins that are different. So you can see there's a couple of things that are missing. So the standard AREF is gone. A0 is no longer where it used to be. D1 and D0 are not where they used to be. D6 and D7. It's actually lost. We lost quite a few pins. A little sad. And then you can see here, this is kind of neat, this ground, it says oh, this is a couple pins, and ground ANA is also a couple pins. We also lost, we didn't lose RX and TX here, but we did lose the standard SPI. So we're going to have to do quite a bit of work to adapt the Arduino core because we lost a ton of pins. We didn't lose all of them, but we did lose the default SPI core pins. And if you remember, we had a video about SIRCOMs. What we would do is assign the SPI device to a different SIRCOM. We have a bunch of different SIRCOMs. The SIRCOMs are here. You can use 2, 3, or 0. Some of them, like the I2C is still here, and that's SIRCOM 3. So that's not available. But there are other pins that we might be able to use. Like these 2 pins we can't use because they're used for SWD. But SIRCOM 5 is available. Maybe we'll recycle SIRCOM 5 into the serial, the serial port, because that was on D0 and D1. And this would be okay, it's you still a UART port, but it's on a different pin. And then, yeah, it's annoying we lost SIRCOM, the entire setup here for SPI. SPI was on SIRCOM 2, but we'll reassign this. So we'll lose some pins, but probably the reason that SIRCOM is gone is because that SIRCOM, the one for SPI, was basically is used internally to connect to this RF device, the AT-SAM, the AT89RF233. It's an SPI device, so that's probably where it went. Okay, next step, we're just going to tie together these VDDs. And I'll look at exactly what the eval board does here. But connect that, and then we'll need a crystal. Looks like, I believe that you need a 16 megahertz crystal for this. I'll look that up in a second. And then there's, of course, this RF section. So, you know, like the nice thing is I didn't move the pins around, so I could kind of paste this in place. I think also you might be able to have one, well, we'll see if the crystal, you can maybe give up. If I don't need to use a 32 kilohertz crystal, and I do need a 16 megahertz, maybe I can just use a 16 megahertz, because you can define which crystal, like what kind of crystal you're using for timing. Like you can set up a PLL off of this 32 kilohertz crystal, or you can use a 16 megahertz crystal and PLL off that. Doesn't really matter. There's also an internal crystal. It's not precise enough for USB. It's precise enough to boot up the device and then do clock dividing and set up the PLL. Which is kind of a neat thing. So that's that. So the next steps, which I won't do tonight, but just FYI, is what I'm going to do. And this is pretty much it. So you're all like, I can start an Adafruit. How hard can this be? Well, I'm going to tell you my secret. Secret is you just look at the eval board. Whatever the eval board does, you should do that. They did all the work already. Why do the work? So you look up the X Pro. I haven't looked up the schematic, but I'm sure it's here somewhere. And you know they have this lovely eval board that's ready to go, and looks like, yeah, you have 2 crystals, and then documents, and then hopefully the schematic is in here. I really hope so, because that would be really sad. I mean, they have a nice image. You can at least see sort of the layout. See, 16 megahertz crystal for RF, 32 kilohertz crystal. So you probably actually need both. What are you gonna do? You have a Balin. Okay, we'll have to spec that out. That's gonna be fun. And is there schematics? I hope there's schematics. There might be in the software download.
Can you answer an unrelated question?
Yeah.
Okay, unrelated question.
Unrelated.
The dot star strips don't have capacitors. Do the APA 102 LEDs not require caps?
Do they not at all? I thought some of them did. I mean, it could be that they're not as sensitive to voltage drops. I'm surprised they really don't. No, they don't. Yeah, you're right. That's interesting. I could have sworn they did. I think, here's the deal. So the WS2812 is, it's a little bit of a marginal chip. I mean, it works, but like, it's not happy. Like you have to, they break a little easily. They have issues with voltage fluctuation. They have issues with input voltage spikes. I think that the APA series LEDs have less sensitivity to voltage variations, which the World Semi chips may. Just put a really big capacitor on the input. Just put like 1,000 microfarad capacitor, and you're pretty good. Or it depends if you're powering it from an external power supply, and that power supply isn't being used for anything else. It won't really matter that much. Okay, that's the question. Oh, yeah, okay. Let's see if I can. Yeah, I really hope there's a schematic in here. Sometimes it's in some other file. Oh, no, there's no schematic. Jerks.
Can you talk about the difference between the dot star and NeoPixels?
Yeah, so dot stars use basically SPI-like. Hold on, let me just see if I can. Design documentation. Found it. Wait. That just links to this page. That's not useful. Why would you do that? That's so mean. There's not actual CAD file. Okay, so I'll probably have to email Atmel and be like, yo, give me the design files. Because they do, hold on. Let me look up something and I'll explain the difference. I have to find out where this, it says software. Oh, maybe. Oh, yeah, here it is. Ooh, wow, they even have like a pick and place, like for all the components. So design document. Oh, so here you go. So this is schematic. So, you know, they don't use Eagle CAD, as you can tell. I believe this is Altium. What is this made with? Why is there so much stuff in my PDF viewer now? Could I hide any of this? Yes, okay. Rubber feet. So yeah, you can, you know, basically here you go. This is the SAM R21 G18, and they just show you, okay, here's how you connect all sorts of stuff to it, and they have notes telling you, you know, this needs to have a USB cable connection. This signal's not available elsewhere. So this is kind of useful. So basically, like, you would go through this and go through each pin and just make sure, like, what do they connect to it? Like, what crystal did they spec? If they spec'd a 20 ppm crystal, spec a 20 ppm crystal. And yeah, basically that's like the next step. So I'll probably do that in the next video I do about this, or I'll do it in between and I'll just show the final thing. But that way you know, if you're following the eval board, you're going to get the best chances of having your first design work, because you're just copying what they did. Like, they obviously thought about this. Like, how many capacitors did they put on? Make sure you have at least that many capacitors. How did they do their power distribution? I mean, like, I might just take the eval board layout and then duplicate it the best I can in Eagle CAD, because, like, why not? Like, you know, if they determine that for the RF plane, like, you know, they used this many vias to stitch and, like, you know, this wide traces, like, of course you want to go and also do some engineering and verify that, you know, this is the correct trace width. But, like, it's going to be a very big hint if they did something and, you know, your numbers don't match up theirs at all. You should be like, maybe I'm wrong. Okay, so the next, so the question was a difference between dot stars and neopixels. Dot stars use a 2-wire protocol, which is not timing specific. You can pretty much take as long as or fast as you want to clock out pixels, whereas neopixels have specific timing, but they only use 1 pin. And dot stars also have a higher PWM and refresh rate. So they're much better for LED painting than neopixels, because you get persistent vision effects, which you can't really with neopixels. Neopixels are kind of blocky. The SK6812s are a little bit better, but they still aren't going to be as fast as dot stars. You can also display data dot stars really fast. You can run them at 8 megahertz or sometimes even faster. And neopixels, you're stuck with that 80 kilohertz clock rate. Woo. All right, so antenna. Yeah, that wasn't too bad. And then, of course, you know, you want to check the data sheet as well for any recommendations. But yeah, so we'll do this up. This will be kind of interesting. So, you know, they have some really nice specs on, like, okay, not only do you need a crystal, but, like, here is the max ESR, the estimated load. You know, so, like, for example, they're like, hey, you should use an 8.2 picofarad capacitor on each side of the crystal. You know, do your own math, but if your math and your product doesn't match this, you're in trouble. So, I mean, obviously you're not going to get 8.2 picofarad capacitors. They don't make them that precise, but you'll get 8. So that's the next step, but having an Eagle object is a good start. We have something to work with, and I'll clear out a lot of this space. I'll put an antenna and the bail and all that stuff and all the extra components that you need. So this will not have any prototyping space. This will probably fill up the entirety of this feather, but it'll have a radio built in, so it's pretty cool. And that's pretty cool. Yeah, that's it. That's all I got.
That's it?
Yeah. 45 minutes.
Let's.
Is there any other questions, or?
Let's see. What's the best? This is non-related, but good question.
That's a good question.
What's the best, easiest ways to learn and understand Python so I can program a Pi, because it's very strenuous.
Because it's very what?
Strenuous.
Very strenuous. Yes, Python is strenuous. There's a lot of online like code academies and like Code a Day and like Code Kata and all that stuff, and that's one way to do it. There's a lot of good books. We carry a book called Python for Kids. You can get it from any bookstore or have them, order from wherever. But so far, people have said they really like it. I mean, it's called Python for Kids, but it's not for kids. It's for adults too. I mean, if you're a kid, that's also great. But if you're an adult, don't feel put off by the fact that it's for kids. It just means it's a friendly introduction to programming. And then once you have a little bit of Python experience, there's actually quite a few Raspberry Pi Python books available that are specifically. It's like one is called like Programming the Raspberry Pi with Python, or something. I'll look up the exact name. And Programming Python. Yes, Python for Kids, so that's a good book. And then Learning Python with Raspberry Pi by Alex Bradbury. So that's a good one, I think. And Programming the Raspberry Pi, Getting Started with Python. And this is by Simon Monk, and he's an author who's written for us, and he writes really well as well. And this is actually not too bad. It's only $15. So this one is probably good. And Python for Kids is a really good one too. So, I mean, like, Python is not, it's not a bad language. You don't have pointers. You don't have memory mapping or memory allocation. So you can't blow your foot off.
Okay. All right. And with that is today's Disco video. Don't forget tomorrow night, 10 p.m. Eastern Time is the final Pi Zero, Pi Hackaday.io contest video. So we're just going to show a bunch of things. It's USB gadget night, and that'll be it. Yeah,
I'm going to maybe do USB gadget, and maybe I'll show another thing, like battery powering. So I have a 2-in-1, and that'll be it. It just you still have many weeks to enter the contest. Go to Hackaday.io and enter up. Put some dot stars in your Pi and go to town.
All right.
Win $100.
And that's that. That's Disco Data. See you soon.
Thanks, everybody. Later. Doot, doot, doot.